Okay. In alternating current, first let us try to talk about your root mean square value of alternating current. Okay. What is the RMS value of an alternating current formula? That means what you do is first you do the square, then you take the mean, then you make it as of your root. Okay. That means I R M S will be equal to, this is root, this is right now for me integral of your I square into dt divided by integral of your dt. This is the formula for your IRMS current. IRMS is equals to integral of your IRMS is equals to under root of your, this will be the mean beta. Integral of I square into dt is nothing but from your mean divided by dt. Clear? See here. I'm taking here current. I need its peak value and I need its RMS value. Okay. Peak current value, peak value, and RMS value. See how we are doing. First one is, like say if I take the current, I is equals to A into sine omega t plus phi. What is its peak value beta? Peak value will be equal to your A. Peak value will be equal to how much for me? Your A. What is the RMS value beta? RMS value will be equal to your A divided by root. Done. Peak value divided by root 2. The same way for the second one. If I'm taking the current like this, I is equals to A into cos omega t plus of your phi. Tell me how to write the peak value of this one. For this one is also A. And how do you write the value of your RMS value beta? For this one it is also A divided by root. Clear? IRMS formula is how much for beta? I'll write here. IRMS is also equal to IRMS is equals to peak value divided by root 2. IRMS is also equal to your peak value divided by root 2. I naught is your peak value of your current. If I'm writing ERMS, ERMS will be equal to E naught divided by root 2. E naught is nothing but peak value of your EMF. Clear, beta? Sure. The next one. If I give you the current like this, I is equals to, it is sum of your A into sine omega t plus B into cos omega t, where A and B are constant beta. So for this one, the peak value will be equal to under root of your A square plus B square. If you get the equation, directly write like this. And peak value will be equal to how much beta for this one? It is your right now under root of your A square plus B square divided by root 2. That means total I can write like this. A square plus B square divided by 2. Clear? Now, if I give you the current like this, I is equals to your A plus B into your sine omega into t. Can anyone tell me its peak value beta? Its peak value will be equal to A plus B blindly. And what is its IRMS current value beta? It is under root of your A square plus B square divided by 2. Okay. So A as it is will be writing, this is a plus, this will be equal to your A square, this is B square divided by 2 under root. Clear? Am I clear, madam?
Yes, sir.
Let me do some problems, you'll get an idea how the problems are being given in this one. Like say if I ask you, find RMS value and a peak value. See, I'm doing only that much which is required for the examination beta. Now we are not in the position to write the definition. What do you mean by AC? What do you mean by DC? And go on like that one. Directly, if it is a problem, how do you approach the problem with the directly formula based? Okay, that level you just try to revise it twice. You'll get an idea how to do the problems on the IC current instead of completely or blindly leaving it. One who has been already completed AC once, it will be sort of a revision for you, and you can give me the answer in the fastest way. The question is right now find RMS value and as well as of your peak value per following cases. First question, number 8. I is equals to your 20 into sine 100t. So give me the answer for this one. I need the RMS value and I need the peak value. Peak value, can anyone tell me better?
20.
Very good. Compare it to the standard equation. I is equals to I naught into sine omega into t. So I naught is a peak value. That will be 20. Very good. Then what is the RMS value, beta? IRMS
20 by root 2.
I naught divided by root 2. So it will be your 20 divided by root 2. 20 divided by root 2 is how much for me? 10 root 2. What it? Achanda?
Yes.
Sure. Second question. One more question. Number B. If I take the value I is equals to 5 plus 4 into sine omega into t. Okay. So now we need the value of your peak value and as well as of your RMS value. How to write the peak value? Beta? Is it not like this? Like A plus B sine omega t. What will be the answer? A plus B. So this value will be equal to how much for me? Peak value will be equal to 5 plus 4 directly 9 ampere. And what is the value of IRMS? IRMS is equals to under root of your, this will be your A square plus B square divided by 2. That is under root of A value is 5 square plus 4 square divided by 2. So that value will be equal to how much for me? Under root of 25 plus 4 square is how much? 4 4 is 16 divided by 2. Isn't it? So it is 2 1s are 2 8s are 16. 25 plus 8 is how much?
33.
33 amperes. This will be the answer. So got an idea how to do the problems? चलो दिन का आंसर చెప్పండి సుందర్గా. If I am giving you the equation something like this, I is equals to 30 into sine omega t plus 40 into cos of your omega into t. Isn't it? You just need to remember this table better. These 4 tables you have given for you now. You just try to remember, practice it. You can do the value of peak value and RMS value without much of your confusion. Now it is in the form of A sine omega t plus 40 into your cos. Isn't it? So what is this one? I can write this form. Third one, A into sine omega t plus B into cos omega t. Peak value will be under root of A square plus of your B square. That means peak value will be equal to I naught is equals to how much? Under root of your, this is a 30 whole square plus 40 wholes. How much it will be better? ఎంత అవుతుంది? 50. Very good. వచ్చిందా? Then tell me IRMS value better. IRMS is equals to how much? See, what is the formula? Third one. IRMS is equals to under root of A square plus B square divided by 2. So this is your under root of your A square is 30 whole square plus 40 whole square divided by your how much? 2. Got it? So this value will be equal to how much beta? Under root of your 30 square plus 40 square is how much for me? 50 divided by root 2. Antena? Because I can
Yes, sir.
like this beta. IRMS is nothing but I naught divided by root 2. No? I naught value already I got 50. So it is 50 divided by root 2. 50 divided by root 2 is how much? 25 root 2 amperes. Done? Done beta?
Yes, sir.
So what is the formulas for the IRMS and VRMS beta? IRMS is I naught by root 2 and ERMS is equals to E naught divided by root 2. E naught divided by root 2. Peak value. Done?
Sir, is it not 70? I naught value.
Why 70 beta? 3 square and 4 square, no? 16 plus 3 square, 9.
Okay.
Isn't it?
Sir, only 25 will be not, sir.
Hmm?
Because under root, no, sir.
Yeah. Under root of your 30 whole square plus 40 whole square beta. I'm taking out under root, no?
Yes, sir.
Got it?
Yes.
Should I do it? 30 whole square is how much? Thirty whole square is how much better? 30 into 30.
900.
900 plus 40 into 40.
1600.
So how much is this one total?
2500.
2500. Isn't it? 5 5 is 25, no? 50 whole square under root.
Yes, sir.
Yes, sir.
Got it? Chalo, next one. Resistor, inductor, capacitor, series AC circuit. Okay. We also call as of your LCR circuit. When inductor, capacitor, resistor, all of them are connected in series combination. Like see, this will be the graph. First one is I'm taking the resistor, then we are taking the inductor, then we are taking the capacitor. All of them are connected in series. And this is connected to the alternating source of EMF. Alternating source of EMF by default, we always write it as E is equals to E naught into sine of your omega into T. Capacitor, inductor, resistor. Okay, so when there is a flow of a current in this one, this is right now for me I. So same amount of the current is flowing in all of them. Potentials will be different. So what I can say in this one, current is same. Current is same in all. Okay, now try to remember the vector diagram for this one better, very important. Like this, if we take it, on x-axis we always take the current vector, that is I. On y-axis we take the potential. Now remember, whenever the current is passing through resistance, the potential will be always like this, VR. Whenever it is passing through inductor, it is VL. Whenever it is passing through capacitor, it will be VC. Blindly you remember like this, but whenever the current is passing through resistor, EMF of the resistor is parallel to current. Whenever current is passing through inductor, EMF of the inductor is 90 degrees ahead of current. Whenever current is passing through capacitor, potential or EMF of the capacitor is 90 degrees lagging with respect to current. Okay, if it is going like this, it will be ahead better. If it is going like this, it will be your lagging. If nothing is there, if there is no angle, theta is equals to 0, that means it will be in phase. Am I clear? Am I clear? Ardhamainda idi?
Yes, sir.
What I am trying to say is, whenever the current is passing through the resistor, what is the potential across your inductor? That is nothing but VR. This is the potential across your inductor. This is the potential across your capacitor. Whenever current is passing through the resistor, current and potential will be in the same direction, but angle between them is 0. Whenever current is passing through inductor, angle between current and inductor is 90 degrees. This one is 90 degrees ahead. Whenever current is passing through capacitor, current angle between current and the potential of the capacitor is lagging by your 90 degrees. Am I clear?
Yes, sir.
I can even redraw this one better. Like say VL and VC are above and below. So I can take the resultant of this one. The resultant will equal to how much one? VL minus VC. And in this direction,
మా
it
అప్పలేమనే తీసేసిన మరి
is VR. Mute yourself
మీరు
better.
చూడకుండా మీరు ఊకే చూస్తారు అది.
Harshita.
Yes, sir.
Done. VL minus of VC. Isn't it? Positive y-axis minus negative y-axis, VL minus VC. And potential across the resistor is along x-axis, VR. The resultant of this one will be equal to this much. This is the resultant. So this is V net. Can anyone tell me how do you calculate the V net better for this one? V net will be equal to anyone. V net will be equal to parallelogram law of vector addition. Angle between them is how much? 90 degrees. Resultant is making an angle of your phi. So V net will be equal to how much better? Under root of your, this one is under root of your, this one is VR square plus VL minus VC whole square. Am I clear? Am I clear? Am I clear with this one, beta? Whenever the current is
Yes, sir.
LCR circuit, VR is along x-axis, angle between them is 0. VL is 90 degrees ahead with respect to current. VC is 90 degrees lagging with respect to the current. Am I clear? అర్థమైందా? No response.
Got it, sir.
ఐఎమ్ గివింగ్ యూ ఎగ్జాక్ట్ నెక్టార్ నాన్న, మరీ నేను డీటెయిల్ గా చెప్పడం లేదు, బట్ ఎంతైతే నేను రాస్తున్నాను అంతవరకు గుర్తుపెట్టుకున్నా కూడా డైరెక్ట్లీ యూ కెన్ డూ సమ్ ప్రాబ్లమ్స్. సమ్ టైమ్స్ వి గెట్ 2 questions from the AC beta. Now remember again this diagram beta, everyone. This one is inductor, this one is capacitor, this one is resistor. LCR circuit. Okay, and it is being connected to the AC like this. Same redrawing the diagram. There is a flow of a current in this one. This is I ampere. Same flow of current I. Same current flow I. Same current is flowing through this one I. Okay. Now just now I told you potential across this one will be equal to VL. Potential across this one will be equal to VC. Potential across this one will be equal to VR. All the formulas I'm writing here directly. Number 1. Ohm's law directly. VR, potential across resistor, is current into resistance. Then potential across your inductor is current into resistance. Here is represented by XL. Third one, potential across the capacitor is right now here I into your XC. Clear? What do you mean by XL beta? XL is known as, anyone? Inductive reactance. And value of XL will be equal to L omega. Omega will be equal to 2 pi into frequency. XC is known as capacitive reactance. అంటే ఇండైరెక్ట్ గా ఎఫెక్టివ్ రెసిస్టెన్స్ అనుకోండి. XC will be equal to 1 by C omega. Omega will be equal to 2 pi into F. Am I clear? XL is known as L omega. XC is equal to 1 by C omega. What do you mean by XL? XL is known as inductive reactance. What do you mean by XC? XC is known as capacitive reactance. Clear? Am I clear?
Yes, sir.
So I'll write here XL is equals to L omega. XC is equals to 1 by C omega. And omega is equals to 2 pi into F. Okay. In India, what is the frequency which we are using in household? 50 hertz. In USA, we'll be using 100 hertz. That is the reason the instruments of your USA will not work here unless and until we use the adapter. Am I clear? Chalo. Let me write the phasor diagram for this one. Remember phasor diagram. Tell me, can anyone tell me the phasor diagram? X-axis we are having resistance. Y-axis we are having inductance. Minus negative y-axis I am having capacitance. That means here I can write as R, and here it will be your XL, and here it will be your XC. Angle between them is here 90 degrees. This one is also 90 degrees. Am I clear? Am I clear? Now see, if I give the condition, if XL is greater than XC, then XL is dominating na beta. So in that case, I can draw like this. This will be equal to R, and above will be equal to XL minus XC. The resultant of this one will be equal to your this one. The resultant is known as Z beta here, which is making an angle of 5. Z and enti? Z is known as impedance. What is known as Z? Z is known as impedance. Okay. Now Z value will be equal to how much beta? Anyone? What is the value of Z? It is under root of your R square plus XL minus XC whole square. Got it? Got it? See in this diagram, XL means what beta? Like this one I have taken this one, na? Diagram. VL minus VC. XL means what beta? I into XL. VC. VC means I into XC. In the place of L, I am taking XL. In the place of C, I am taking XC. Angle between XL and XC is equal to how much for me? 180 degrees. Angle between XL and R is how much? 90. Angle between XC and R is how much? 90. Can I say that XL is 90 degrees ahead of R? XC is 90 degrees lagging with respect to R. Can I tell like that?
Yes, sir.
What is Z? Z is known as impedance. If the condition is given for you in the problem, if XL is greater than XC, then impedance for that one is under root of R square plus XL minus XC. Clear? You know the value of XL. XL is equals to L omega. XC is equals to 1 by C omega. Tan phi from the figure. Tan phi is equals to XL minus XC. Y-axis divided by x-axis. That is nothing but R. This is the value of your tan phi. Or else I can even write in terms of impedance. Tan phi is equals to L omega minus 1 by C omega divided by R. If omega is given for me, I can calculate the tan phi like this. Okay. Z can also be written as beta. Z is equals to under root of your R square plus XL minus XC. XL value is how much beta? See here, XL value is L omega. So it is L omega whole square minus 1 by C omega whole square. This is total one term. Like this. Am I clear? And we define one more term here called as cos phi. Cos phi is known as power factor represented by R by Z. Cos phi is equals to R by Z. What we call this one? Power factor. Am I clear? Am I clear? Mala sir. For LCR circuit. For LCR circuit. Potential across the inductor is known as VL. Potential across capacitor is known as VC. Potential across the resistor is known as VR. Now what are the formulas for that one? VR is calculated by I into R. VL is calculated by I into XL. VC is calculated by I into XC. And what do you mean by XL? XL is known as inductive reactance, L omega. XC is known as capacitive reactance, 1 by C omega. Omega value is written as what beta? 2 pi F. In India, the frequency is 50 Hz. A phasor diagram beta. Just remember, for resistor, it is along x-axis. For inductor, positive y-axis. Capacitor, negative y-axis. Angle between XL and XC is 180 degrees. Angle between your XL and the resistor 90 degrees ahead. And angle between inductor, capacitor and resistor is 90 degrees lagging. If I give you a condition that XL is greater than XC, then this will be diagram. XL will be here right now and R will be here. And Z is known as resultant resistance that we call in AC as impedance beta. Resultant resistance. Z is nothing but what for me? Resultant resistance. In AC, that resultant resistance is called as impedance. Impedance is given by the formula Z is equals to under root of R square plus XL minus XC whole square. XL value is L omega, XC value is C omega. So if I substitute that values, I can redraw this one like this. Z is equals to under root of R square plus L omega whole square minus 1 by C omega whole square. If I'm writing angle, tan phi is equals to XL minus XC. Or else I can write tan phi is equals to your L omega minus 1 by C omega into your R. Which is another Am I clear with this one?
Yes, sir.
Yes, sir.
Is another one power factor. What is a power factor? R by Z. R is known as resistance. Z is known as impedance. Machinda, what it beta? Chalo, try to do this problem fast. There is a resistor, there is an inductor, there is a capacitor. Okay, and this is connected to your alternating circuit. This is a symbol of alternating circuit beta. Potential across this one is given for me, let's say for example 40 volt. Potential across the inductor is given, let's say 60 volt. Potential across your capacitor is, let's say 30 volt. This is the capacitor, this is inductor, this is your resistor. Okay, am I clear?
Yes, sir.
Now tell me the resultant EMF of this one. So how do you write beta? Who is more here? XL is greater than XC na beta? From the diagram you see. 60 volt,
Yes, sir.
30 volt. When XL is greater than XC, what I told you? When XL is greater than XC, this is the graph we write. So I need to calculate the resultant impedance. So I'll draw the impedance like this. Here it is the potential of resistor. It is 40 volt. Here we are having the potential of inductor. In the down we are having the potential of capacitor. XL is greater than XL. That means this diagram will become like this. So this will be your 40 and here it will be your 60 minus 30. That will be equal to 30. So resultant of this one will be equal to this much, making an angle of your 5. So this is the resultant resistance of that one, Z. So what will be the Z beta? Z is equals to under root of your R square plus XL minus this one. That is 40 whole square plus 30 whole square. So how much will be beta? Under root of your same. This one is 1600 plus this is 900. So this will be equal to how much?
50, sir.
Volt. Okay. Can anyone tell me what is the net potential beta? V is equals to VR plus VC plus VL. VR is how much beta? 40. VC is how much for me? 30. Potential of inductor is how much for me? 60. So total potential will be equal to how much for me? 130 volt. Got it?
Yes, sir.
So I hope you got an idea how to calculate the impedance of the given conditions. Got it? Phi will be representing what beta? Phase angle. Phase angle between the net voltage and as well as of your net current. Any doubt? Can anyone tell me how to calculate the tan phi value? XL minus XC divided by R. Power factor cos phi is equals to R by Z. Done beta? Shall I do
Yes, sir.
one? Shall take it? Everyone try to do it out beta. Let's say for example there is a resistor, there is an inductor and there is a capacitor. And this is connected to your AC source. Okay, this one is 200 volt. In the above problem, what will be this potential beta? This is not given. This will be equal to net now. Sum of this all, that will be equal to how much for me? 130 volt. Got it?
Yes, sir.
Let's see this one. Take your time and try to do it. There's no hurry. This one is say for example 5 ohm. This one is 20 ohms. This one is say for example 8. Clear? Resistance 200 volt. Resistance of the inductor. This is resistor. This is inductor. This is capacitor. Okay. My question is find number 1 VRMS. Number 2 peak voltage. Number 3 impedance. Impedance means Z. And number 4 IRMS. Root mean current will be equal to how much? Next one is peak current. Okay. The next one is phase difference between current and voltage. Between your current and voltage. This is the question. This is a given diagram. Can anyone tell me VRMS will be equal to how much better? First one. VRMS
200
is
volt.
equals to V0 divided by root 2. Okay. So what is VRMS given for me? 200. So the potential what is given? This will be acting as of your VRMS. So VRMS will be equal to how much for me? 200 volt. So peak value I can calculate. Peak value is root 2 times of VRMS. This is for 2. So peak value is equals to root 2 into VRMS is 200. So the answer will be 200 root 2 volt. Clear? And number 3. Number 3 is what? Impedance. Impedance means who is larger beta in this one? Can you tell me? XL is how much for me? 20. XC is how much for me? 8. That means XL is greater than XC. XL is greater than XC. That means here it will be equal to 5. Here it will be equal to how much for me? 20 minus of 8. This will give me the impedance. Making an angle of your 5. This will be the Z. 20 minus 8 is how much better? 12. So what is an impedance for this one? Z is equals to under root of your R square is 5 square plus XL minus XC is nothing but 12 whole square. So how much I'm getting, you see? Under root of 5 5 is 25. What did everyone see how much I'm getting for this one? How much better? 12 square is how much?
144, sir.
144.
So now 144 plus 25 is how much?
169.
169. Root 169 is
13, sir.
13 volts. Got it? Impedance, not resistance. It will be your ohms. Impedance is the resultant resistance, no? So unit will be equal to your ohms. So that is the third one. Fourth one is what beta? IRMS. How do you calculate IRMS beta? IRMS is equals to VRMS divided by Z. Ohm's law I am applying. V is equals to I into R. So IRMS is equals to VRMS value is how much? 200. Z value is how much for me? 13. So it is 200 by 13 ampere. Fifth one. Peak value of a current. How do you calculate the peak value of a current beta? If I know the value of IRMS, IRMS is equals to I naught divided by root 2. So peak value will be equal to I naught is equals to root 2 into IRMS. That is equals to root 2 into 200 divided by 13. Okay. So the answer for this one is how much? 200 root 2 divided by 13 amperes. This will be the answer. Sixth one. Phase difference is asking. How do you calculate the phase difference, beta? How do you calculate the phase difference? Cos phi is equals to R divided by Z. R value is given in the problem how much? 5. Z value is how much? 13. So phase difference will be equal to cos inverse of pi divided by 13. This will be the value of your phi. Am I clear?
Yes, sir.
Got an idea?
Yes, sir.
Will you do one problem now? Everyone got an idea how to do if such type of circuit is given. You got an idea how to calculate VRMS, IRMS, peak value, impedance, all the given conditions. Now see, IRMS when peak value is not given, I'm using the formula. IRMS is equals to VRMS divided by Z. And IRMS is equals to how much for me? I naught divided by root 2. How do you calculate the phase value? Cos phi is equals to R by Z. Clear? So I'm giving you one question. You please try to do on your own and let me know the answer. Okay. This is your resistance. Then this is your inductor. This is your capacitor. This is connected to your some AC source. Randomly I'm giving so that it will be easy for your calculation. 200 volt. I'm giving even the frequency that is 500 divided by pi hertz. Okay. This is the resistance. This one is say for example 6 ohm. This one is say 12 millihenry, and capacitor is like say 250 microfarad. That means it is C value, it is L value, it is R value. Clear? My question is find number one, impedance, and number two, current. So from this one there is a flow of current, na? This current I. And number three, phase between current and voltage V. Will you do it? Come on, try to calculate the impedance. It is LCR circuit. For LCR circuit, how do we calculate the impedance beta? Z is equals to, what is the formula? Under root of R square plus XL minus XC whole square. R is given in the problem. Given in the problem, R is equals to 6 ohm. XL is not given. XL is equals to L omega. L value is 12 millihenry. So it is your 12 into 10 to the power of your minus 3. 10 to the power of minus 3 into omega. Omega is 2 pi into F because frequency is given in the problem for me. So it will be equal to 12 into 10 power minus 3 into 2 pi into frequency. Frequency is 500 divided by pi. So let's see how much I'm getting the XL. And the student XL. This pi will get cancelled. Isn't it? Two fives are 10. So it is 10 means 10 power minus 3, 2, and this will get cancelled. So it will be equal to 12. Got it? Arthamainda? See, pi and pi gets cancelled. 2 fives are 10. Then already 2 zeros are there. So it is 3 zeros. 10 power plus 3, 10 power minus 3. It will get cancelled. So remaining is only 12. Got it? Then calculate XC. XC is equals to 1 by C omega. That is equals to 1 by omega is given how much for me beta? 2 pi into your F. C is equals to 250 microfarad. 250 into 10 power minus 6 into frequency is 2 pi into your F. So that will be equal to 1 divided by, this is 250 into 10 power minus 6 into 2 pi into F value is given how much for me beta? 500 divided by 5.
500 by.
So this pi will get cancelled. 2 fives are 10 again. We see the calculation. 2 fives are 10, 10 power 3. Here it is 10 power minus 6. So this total will get cancelled. And here instead of minus 6 will get minus 3. Done. So this value will be equal to 1 by, this is 250 into 10 power minus 3. So 10 power minus 3, if it goes up, this will become for me 1000. 1000 divided by 250. This zero will get cancelled. So
4.
it is for me. 25 ones are 25 fours are. So XC value is equal to how much for me? 4 ohms. So once I get that one, I can calculate the value of Z beta. Z is equals to under root of your, this one is R square plus XL minus XC. What is the value of XL I got?
12.
Beta. XL is more or XC is more?
Excel.
XL.
XL minus XC. You need to take care of that one while doing problem. Whether I need to do XC minus XL or XL minus XC, that will be.
Answer is 10, sir.
Okay, very good. XL value is how much right now for me? 12 minus XC value is
4.
4 whole square. So it is equals to under root of, what is the value of R?
6.
36.
12 minus 4.
8.
It is 8 square. So it is under root of 6 6 are 36, 8 8 are 64.
64.
Root 100.
Root 100.
How much
10.
it is? 10 ohms. Got an idea? So first question
Yes,
is
sir.
find the impedance. The next one is current I need. How do you calculate the current right now in this one? What type of the current it will be reading beta in this one? IRMS. So IRMS will be equal to VRMS divided by Z. What is VRMS given in the problem beta? VRMS, this is 200 volt will be reading as always VRMS. So that is 200. So it is 200 divided by impedance. I got how much right now? 10. So this will be equal to how much for me? 20 amperes of current is flowing through the circuit. Am I clear? This current
Yes,
will
sir.
so IRMS current. The potential will be equal to VRMS. The next one is what is asking? Phase difference between I and V. Okay. Cos phi is equals to what is the formula? R divided by Z. What is the value of R? 6. What is the value of impedance? 10. So 2 3s are 2 5s are. So this will be 3 by 5. So cos inverse is equals to 3 by 5. Isn't it? That means phi value is how much better? Phase is equals to cos inverse of 3 by 5. Or tell me what is the value of phi? Cos 3 by 5. Cos phi is equal to 3 by 5 means phi must be equal to how much? 53 degrees. Got it? Done beta?
Yes, sir.
So almost all half of the chapter you got an idea how to do in 2-3 problems only. Need not again separately partify the formulas on that one. Kagavate pancham practice gavala that will be done by doing this one. I'm anyhow recording this one. So you can see the recording twice and thrice so that you will get an idea how we are doing. If I go in detail explanation, it will take the time better. Now you can complete your AC literally in 15-20 minutes after listening the lecture. Okay. Sure. Next one is about power in AC circuits. Power in your AC cell. Formula gurtunde evarkaina power formula. I'll make a little bit larger. You need to remember this one. Power formula beta. P average is equals to VRMS multiplied by IRMS multiplied by cos phi. So this is the formula for your power. P is equals to VI cos phi. What is cos phi beta anyone?
R by Z.
R by Z. What is the name for that one?
Power factor.
Isn't it? So this one is right now for me what? Average power consumed. Average power consumed in the AC. Cos phi is equals to how much better I told you? Cos phi is equals to R divided by Z. Z is known as impedance. Clear? Okay. See you. Come to the normal problem. Whenever I'm writing P, P is always equals to VRMS into IRMS. Clear? I'll do in detail so you get an idea. Next heading. Resonance in AC circuit. What do you mean by resonance beta? Same. Initial must be equal to your final. Okay. In AC circuit, that means LRC. LCR circuit. So let me draw the diagram. L is there now. First, so I'll try to take inductor first. So this is your inductor, then capacitor, then resistor. Connected to your alternating source of EF. So this is your XL, this is your XC, this one is your R. Inductor, capacitor, resistor. Clear? How do you calculate the impedance for this one better? Roughly you tell me faster. This will be equal to your R. Here it will be your XL. Down will be equal to your XC. So do you calculate the impedance for this one? Impedance is right now for me Z. Make an angle of your phi. So Z value will be equal to under root of your R square plus XL minus XC whole square. Clear? Cos phi value will be equal to how much beta? XL minus XC divided by R. Condition is that if XL is greater than XC. Am I clear? So this is the formula for your impedance, and this is the formula for your, sorry, this is tan phi, no, not cos phi. This one is your tan phi. Okay, so this will be your XL minus of XC divided by R. Clear? What do you mean by resonance beta? Condition for the resonance. I'll write here. At resonance, impedance Z of circuit is minimum. If Z should be minimum, means what should be the condition beta? Can anyone tell me? Condition for resonance. Gurtundala. You're gonna Gurtunda? XL must be equal to XC beta. XL must be equal to your XC. This is the condition for resonance. Am I clear? XL and NT, omega into L. XC means 1 by C omega. So if I take omega on one side, omega square is equals to 1 by C L. Or LC I can write. So omega will be equal to how much better? 1 by under root of your LC. So this is your resonance condition. Okay. Omega is known as angular frequency. So if I need to just calculate frequency, 2 pi into your F naught is equals to 1 by under root of your LC. So resonant frequency is equals to F naught is equals to 1 by 2 pi multiplied by 1 by under root of your LC. So this is your resonant frequency formula. 1 by 2 pi into under root of your L into C. This frequency is known as what for me? Resonance frequency. Am I clear? So what is the resonance frequency? F naught is equals to 1 by 2 pi under root of your L into C. And what is an angular frequency formula? Under root of 1 by under root of your LC. So at resonance, I can say that at resonance, impedance will be equal to your R. So in this case, impedance will be minimum. So when will be the impedance minimum? What will be your answer? Z must be equal to your R. That means what is the value of cos phi beta? Cos phi is equals to R divided by Z. So it is Z divided by Z. That is equals to 1. So cos phi value will become how much for me? 1. Okay. At resonance, what is the power factor value? 1. So if cos phi value is 1, then average power will be equal to how much for me? VRMS, IRMS into cos phi. So for LC circuit in resonance, power will be equal to VRMS into IRMS. Cos phi value will be equal to 1. Got an idea how I am writing P is equals to VRMS into IRMS? Now tell
Yes,
me,
sir.
is how much better? VRMS is equals to V naught divided by root 2 and IRMS is equals to I naught divided by root 2. Isn't it? Am I clear?
Yes, sir.
Now can I write the IRMS in terms of resistance beta? Because V is equals to I into R. This will be VRMS is equals to IRMS into R. Isn't it? So IRMS will also be written as what beta? IRMS is equals to VRMS divided by resistance. So this formula can also be written as right now for this one. P is equals to VRMS multiplied by IRMS. That is nothing but VRMS divided by R. So power will be equal to VRMS whole square divided by resistance R. Got it? I can even write this one like this. P is equals to VRMS into IRMS. That is equals to VRMS is nothing but what? IRMS into your R into IRMS. So that will be equal to your IRMS whole square multiplied by resistance. This is the power in resonance condition, either in terms of potential or in terms of your current. Clear, beta? Am I clear?
Yes, sir.
So P is equals to VRMS, IRMS, this one. And for resonance condition, cos phi value will be equal to 1. That means for in resonance, impedance will be your minimum at your resonance condition. Clear, beta? Sure. Graph of your impedance versus frequency. Okay, just take this diagram. Beta. On y-axis, we are taking impedance. On x-axis, we are taking the frequency. The graph will be something like this. Okay, it will be minimum somewhere here. So Z minimum must be equal to how much for me? R minimum. So at that time the frequency will be peak value F naught. That is equals to 1 by 2 pi under root of your L into C. So in this condition, Z will be equal to how much beta? Under root of your R square plus of your XL minus of XC whole square. Isn't it? That means Z value will be equal to how much for me? Z value will be equal to under root of your R square plus L omega minus 1 by C omega whole square. Okay. If frequency is 0 beta, then impedance will be infinity. Remember, if frequency is infinity, then impedance is also infinity. Clear? Just remember this graph, and these are the formulas which you need to remember for doing the numericals. Am I clear, beta?
Yes, sir.
At 10 o'clock session, we'll try to continue with this part of AC, and we'll try to see how was the questions in 2024 and 2023. And small topic is left out, that is about your quality factor, sum of this relation. Then we'll try to do the problems of 2024, 2023, and 2022. So we'll get a rough idea that whether it is a purely formula based or little bit of your conceptual. Even if you have a time with you, please try to take the material and try to see that how was the questions in your, what do you call that one, 2024. So we'll get rough idea how the problems have been based. And if you want to helpful అవుతుందా లేదా అనేది కూడా మీకు క్లారిటీ వచ్చేస్తుంది. Am I clear?
Yes, sir.
Paranya, నువ్వు వింటున్నావా? మార్నింగ్ క్లాస్ రావడం లేదు. యూఆర్ నాట్ మార్నింగ్ యువర్ గ్రాండ్ స్టార్ట్ చేశాను నేను.
Yes, sir, I'm listening.
మార్నింగ్ పూట రానా ఇట్లా ఒకసారి వింటుంటే
Okay,
ఫార్ములేషన్ రివైజ్ అవుతుంటాయి. గ్రావిటేషన్ కి దానికి కూడా. ఇంకో 10 గ్రాండ్ టెస్ట్ I'll send you and please try to do it on your own. Okay?
Okay.
Have your dinner, take a little bit of a rest, and come back at 10 o'clock. And make sure that even maybe on the Sunday or maybe coming days, we'll be having the long session of a class like name of marathon. where we'll try to do the second year some important topics revision in fast way, like as I'm doing AC. The same way, first year topics also like thermodynamics, kinetic theory of gases, units and dimensions, work power, energy, rotation, gravitation, elasticity, surface tension. This all chapters revision which are very much required, and the formulas on which we are expecting the problems very frequently are formula based on that will try to revise and try to write it so that you will be recollecting all the formulas at a stretch. Okay. Sure.
Okay, sir.